Hello, this is section 4.2, number 16. This is 16 from the online work, number 59 from the book work. So it says use the limit process to find the area of the region between the graph of the function and the x-axis over the given interval. And it's g of y equals 4y squared minus y cubed, y being between 1 and 3. So this is actually a pretty challenging problem because we're using the limit process, and this can be a little intimidating for people. Fortunately, we don't do much of this after 4.3, and we get to go on to the other definitions. And let's see the shortcuts we use for finding the area under the curve. And this graph is something like this. And we're going to go from, let's say this is 3 and this is 1. We want this region here. Okay. So first we want to talk about our delta y is going to be 3 minus 1 over n, which is 2 over n. Sorry, didn't hit the microphone there. So yi is going to be the left part of the interval, or I should say the bottom part of the interval, 1, plus 2i over n. So it starts at 1 and goes up by 2i over n, I being whatever interval we're talking about. So in general, our sum is going to be the sum as I goes from 1 to n of g of yi delta y. That's going to be the sum as I goes from 1 to n of g of 1 plus 2i over n times our 2 over n. That's our delta y. So it's going to be the sum as I goes from 1 to n. That's an I, by the way, not a t. I goes from 1 to n of, well, what's our g? Our function, as it says up there, was 4y squared minus y cubed. So it's going to be 4 times, and instead of y we have 1 plus 2i over n. So 1 plus 2i over n squared minus 1 plus 2i over n cubed. We're going to multiply that quantity by 2 over n. I want to point out that 2 over n is not affected by the i's, so it's essentially a coefficient and can be factored out. So I'll put it out front of the summation. 2 over n times the sum as I goes from 1 to n of 4 times 1 plus 2 times 2i over n plus 2i over n squared. If it helps, you can call this middle term, if it helps to see it, the binomial expansion, 1 times 2 times 2i over n, or I should say 2 times 1 times 2i over n. Like it's 2ab, so it's a squared plus 2ab plus b squared. Okay. And then we have our minus, this is a cube. So we have to do the binomial expansion for a cube. And that's 1 plus 3 times, like 1 squared, times 2i over n, plus 3 times 1 times 2i over n squared times, or plus 2i over n cubed. So that's just a binomial expansion. Binomial meaning two terms. So we have, if we distribute through, well, let me finish that the multiplication. 4 times 1 plus 4i over n plus 4i squared over n squared minus 1 plus 6i over n plus, that's 4, 2 squared is 4, so 3 times 4 is 12. I squared over n squared plus 8i cubed over n cubed. So it's 2 over n times the sum, I goes from 1 to n, of, distribute the 4 through, 4 plus 16i over n plus 16i squared over n squared minus, I'm going to distribute this negative through, 1 minus 6i over n minus 12i squared over n squared minus 8i cubed over n cubed. And put a parenthesis there instead of a bracket. Two over n times the sum, I goes from 1 to n, of 4 minus 1 is 3. And we have 16i over n minus 6i over n is 10i over n, plus 16i squared over n squared minus 12i squared over n squared is 4i squared over n squared. And we just have this minus 8i cubed over n cubed left. And now it's just a matter of, each term having the sum expanded. And if you recall, the sum I goes from 1 to n of a constant is just going to be c times n. The sum I goes from 1 to n of I is going to be n times n plus 1 over 2. The sum I goes from 1 to n of n squared is n times n plus 1 times 2n plus 1 all over 6. And the sum as I goes from 1 to n of n cubed is n squared times n plus 1 squared all over 4. So we're going to have this 2 over n still out front. Now, this sum of 3 is going to make it 3n. The sum for the next term is going to be 10 over n. So essentially 10 over n is just a coefficient. We're looking at the sum of the I. It's going to be this right here. Oops, didn't mean to do that. Stop it. Okay, times. It's n times n plus 1 over 2. Plus, then we have our 4 over n squared, times, we have the sum of an I squared. That's going to be n times n plus 1 times 2n plus 1 all over 6. And then minus 8 over n cubed times the sum for an I cubed. And that's going to be our n squared times n plus 1 squared all over 4. So it's 2 over n times 3n plus. Now this 10 and the 2, I'm going to reduce those. Makes it a 5 here and a 1 there. And of course the 4 and the 6, we can reduce that. Makes it 2 and a 3. 8 and the 4 makes that a 2 and a 1. So we end up with 5 times n squared plus n, I just distributed, over n, plus 2/3, not 4/3, 2/3 times, and this distributes out to be, I've worked this out already, 2n cubed plus 3n squared plus n all over this n squared minus, and then we have a 2 times, and this expands to become n to the 4th plus 2n cubed plus n squared all over n cubed. So you're probably thinking, whoa, look at this. We have an n, we have n squared over n cubed over n squared, n to the 4th over n cubed. Oh wait, if we took the limit as n goes to infinity, we're going to be in trouble. Well, not really, because we have this 2 over n sitting out here. So if we distribute the 2 over n all the way through, That's going to be, by the way, this is still our S of n. That's 2 over n times 3n. So 2 over n times 3n plus 2 over n times 5 times n squared plus n over n plus 2 over n times 2/3 times 2n cubed plus 3n squared plus n all over n squared. Now it's minus 2 over n times 2 times n to the 4th plus 2n cubed plus n squared all over n cubed. So S of n equals what? The n's divide out here. So the first one's going to be just a 6 plus 2 times 5 is 10 times n squared plus n over n squared plus 2 times 2 is 4 over 3, so 4/3 times 2n cubed plus 3n squared plus n over n times n squared is n cubed minus 2 times 2 is 4 times n to the 4th plus 2n cubed plus n squared all over n times n cubed is n to the 4th. I'm going to give myself some more worker space here. And so we can simplify this a little bit, and then we're going to go to a limit next. 6 plus 10 times what? Well, if you separate this out, that's n squared over n squared is 1 plus n over n squared is 1 over n plus 4/3 times 2n cubed over n cubed is 2 plus 3n squared over n cubed is 3 over n plus n over n cubed is 1 over n squared minus 4 times n to the 4th over n to the 4th is 1 plus 2n cubed over n to the 4th is 2 over n plus n squared over n to the 4th is 1 over n squared. So now that we have that, we're going to take the limit as n goes to infinity of our sum S of n. And that's going to be the limit as n goes to infinity of 6 plus 10 times 1 plus 1 over n. I don't like the way that looks. 10 times plus 4/3 times 2 plus 3 over n plus 1 over n squared minus 4 times 1 plus 2 over n plus 1 over n squared. So as n goes to infinity, what do we have? We have 6 plus 10 times 1 plus 1 over infinity is 0 plus 4/3 times 2 plus 3 over infinity is 0 plus 1 over infinity is 0 minus 4 times 1 plus 2 over infinity is 0 plus 1 over infinity squared is 1 over infinity, which is 0. So it's going to be 6 plus 10 plus 4/3. Nope, take it back. It's 8/3. 4/3 times 2 is 8/3. Minus 4. That's 6 plus 10 is 16, minus 4 is 12. So 12 plus 8/3, which is 36/3, plus 8/3 is 44/3. And that is the area of the region. Okay, I hope that helps. Thanks.